Hey, good morning and happy Sunday. This is PFG Live, the video podcast that asks the question, if you're in a curved space-time continuum, what is flat? Welcome aboard, and welcome to, let's see, we got a DBX reporting from White Plains. Winds are variable at 5 knots, 2-mile visibility in mist. Arthur G. says, me Tarquis, I'm lazy. Lima Foxtrot Sierra Lima. Reporting CAVOK. By the way, that's basically what we call VFR conditions. Emmanuel says 26 degrees science with 81% relative humidity in Bangalore, India. Wow. Robert Simpson is here from near Detroit with 26.44 degrees C. We're going to calibrate you. Unix Carbide in Williamsburg, Brooklyn says it's muggy, 80 degrees, 79% relative humidity. Ox Tools reports 20 degrees science, 61% relative humidity in a light breeze. Aaron says 21 degrees and cloudy in Calgary, Canada. Josh in southern Manitoba is reporting at weather station. I think we established this was a weather station. Charlie X-ray Mike Delta. It's 3 miles an hour. 3 knots of wind, 24 degrees science, 15 degrees science dew point. Evils in Ghent, Belgium reports 27 degrees, 27.2 degrees and 12.2 degrees science dew point. Tucker is with us from the Buffalo, New York, 78 degrees Fahrenheit and sunny with few clouds in Buffalo. I'm going to switch over to the other guys. Let's see. We got John Thawley is with us. 76 degrees and sunny in Santa Ana, California, the county seat of Orange County. Welcome. Torsten is with us from Germany. Hello, Torsten. Art that makes art. Wes is with us. 76 Frankenstein and beautiful in South Central Idaho. Have an onion. Bart Harkema is with us. Welcome. 21 degrees science. And 20 U. Does that mean 20%? I don't know what that means. Is that dew point? Hello from Seattle. Hassan, welcome. 69 and a little cloudy. That's not bad for Seattle. It's usually a lot cloudy. Wes says, Bedata. Who else do we have down here? We have Paul Morley says 100 degrees Fahrenheit in Dallas. Oh my gosh. We're going to send you ice cubes. Dale, 21 degrees science and smoky in Edmonton, Alberta. They're getting a lot of wildfire smoke in Edmonton right now. Robin reports a rather detailed weather report. He says it's nice. Thomas Hardy says 19 degrees science, 68% relative humidity in Karlsruhe, Germany. Welcome, sir. Daniel F., 21 degrees science, 46% relative humidity in London, UK. Welcome. Evils teaches us it's U is short for the Dutch for hour, like H in English. Thank you for the lesson. We appreciate that. Did we capture everybody? Here in my town, it is currently 72 degrees, 79% relative humidity. Manchester Airport reports winds calm, visibility 6 miles, light rain, mist scattered at 1500, broken 6500, overcast 11,000, temperature 21, dew point 18, altimeter 29993. Gobbler House Farm, CJ Stevens. Oh, this is CJ Stevens' wife checking in from East Tennessee. It's 77 and raining. Thank you for being there. I appreciate that. All right. Well, welcome aboard, everybody. This is the PFG Live. We do this every week, if you can believe it. And we enjoy talking about precision and machining and tool making and stuff like that. We have a special show today, and I'm going to keep the normal preliminaries to a minimum. We just finished up a batch of PFG Stones, regular PFG S4s, the regular 4-inch stones. Those are going out. So that will bring me up to date. We are going long today, so if you expect us to wrap it up in 1 hour or not, it's going to go long. And that's about it. That's all the details we have to get out the door. Mix Workshop is checking in from Saratoga Springs, New York. 73 degrees Fahrenheit and cloudy. I used to fly gliders not far from you over Saratoga Springs. And with that, welcome everybody in Discord. Of course, we have our principals in Discord, Mr. Ox Tools, Tom Lipton. We have Robin Renzetti, Unix Carbide, Evils, WidgetWorks, Josh, Robert Simpson, DVX, Tucker, Proteum Machining, Dylan, welcome aboard. Almost Machining, Pert Near. Emmanuel is here. Thomas Hardy, Carl Tauber, Paul Morley, Daniel F., Arthur G., and Aaron W., all in our Discord server. If you are a Discord user and you want to use our Discord server, head over to our links page at pfg.gg/links. So today, as you know, we have Tom Lipton and Robin Renzetti, and we're going to do something special today. They're going to be discussing a particular problem that they've been working on and collaborating on. And our jobs is to not only learn from it, but learn how the collaboration works between two people skilled in the art. And I'm really excited about that. So with that, I'm going to bring in Mr. Tom Lipton from somewhere in the woods of California. Tom, welcome aboard.
Well, thank you. Well, good to see you all.
So give me a description of what we're going to be looking at today.
So, yeah. Well, I was going to tell a little story, well, at least how I got involved with this particular project with Robin. So just to be clear, this is two different approaches to a common problem, and as you've all heard, there's many ways to skin cats, right? And these are just two ways that two different people have kind of come up with. But the interesting part is, and this is what we thought would make a good I don't know, podcast or whatever you call this. Presentation here, right, is kind of the process of how, well, certainly myself and Robin kind of approach these kinds of problems. And for those that don't know, Robin and I have been designing various pieces of equipment pretty much our full adult lives, I would say, and very different kinds of equipment, certainly. And but Robin and I talk pretty regularly, and we both enjoy that creative process that goes with mechanical design. I'll just shorten it up to mechanical design, where you are posed with a problem and you start attacking that problem, and then discarding ideas and adding ideas and cross-pollinating, and then maybe you talk to your friend, and this is the situation here, and they make you think about some other aspects, and in the end, hopefully you end up with something that's useful. And now, part of this is that there's, every design has a set of requirements, right? And I think that's one of the interesting aspects of this particular problem, is that my design requirements are a little different than Robin's, okay? Which makes for what I would say two kind of distinctly different designs for the same article, okay? And, not to keep you guys in suspense any longer, what we've been working on is a cylindrical grinding fixture that goes on the surface grinder or on other magnetic chuck appliances like a sine plate or something like that. So, like I said, I wanted to start out with a story because I think it's relevant in this case. And so a while back, a friend of mine called me and said, "Hey, I'm moving my shop. I got to get rid of a bunch of stuff. look, get your truck and your trailer and get down here, right? And so I did, and I ended up with some really interesting pieces of equipment. And but one of those, and without diverting into all that, one of the things that I got from him was the more tools version of a cylindrical grinding fixture that goes on a surface grinder. And I'm going to share a quick picture of it. Let's see here. I believe I have a picture up in one of my other windows. And let's see here. I think that should do it.
Yep, it's coming up.
Let's see if you guys can see this thing. Okay. So this is the more version of that. Okay. And it's very nicely made. Per more standards, I'm sure it's been fussed over very a lot. So anyway, I ended up with one of these, and I already have one. So let me see. I'm going to take this off the screen, and I already have one, and the one that I have is pulling up a picture. Go back to this. Share my screen again. Is one that's made by Herrig. Well, it's actually not made by Herrig. Herrig bought them from a company called Atco, and I have the Atco version of this. And a lot of you guys have probably seen these here. Okay,
I have one of those.
So you have one of those. Okay,
yeah, I do.
Great. So the basic ingredients here is it's got a base plate that guides the centers. And then it has an electric motor that you can change directions on, and then it has a driving plate that drives your shaft or your article or whatever, under the wheel. Okay, so you set this up on the surface grinder, you align it to the machine, and then you put your work in there. In this case, the left-hand center is spring-loaded, so that it puts a little pressure on the shaft, and then it's usually driven through a what we would call a grinding dog or a dog that interfaces with the plate. So anyway, I ended up with this. This Moore grinding fixture. And I was talking to Robin via text or whatever, and since I already had this Atco version that works pretty reasonably well, I said, "Hey, Robin, are you interested in this thing? I'll send it to you, right?" And to my surprise, he said, "No, thank you." He said, "No, thank you. I'm working on my own that's less clunky than the Moore version." And so my little antenna popped up and said, "Ooh, what is Robin working on?" Right? He sent me a couple of screenshots, and I was like, "Okay, whoa, that's interesting because that's interesting, right?" And okay, so that I don't know what was that. That's a couple months ago, 2 months ago, 3 months ago, something like that. I don't know. Anyway, fast forward a little bit, and a friend of mine who owns a shop asked me to grind a capto holder that for a gear hob. He does some gear hobbing, and he wanted a one-piece arbor for a gear hob. And he said, "Hey, can you grind this shaft or well the arbor part of the capto holder?" And I said, "Yeah, sure." And it turns out that the thing was just a little bit too long for the electric centers, and so I had to jury rig something. So I got really annoyed, and that's usually the start of hey, I could do better than this, right? And that's how all these kind of designs kind of start: is hey, maybe I can do better than this, or nothing exists that will work for what I need. So you design something and you engineer something and you build it, and that kind of leads us up to the present here, and these two different approaches to a similar problem. So anyway, that's the problem that we've attacked, and then what I guess I would like to show is um, I think, and I think it's important here is because it all ties in with the story here. Okay, um, so to me, that every design has kind of a progression, right? And you have the very early stages of it, then you have the it's kind of like chess, right? You got the opening, and then you got the middle game, and then you have the end game before you start building things. And so all good things start with a sketch, right? So what I'm going to do is I'm going to show my progression in sketches, and then I guess I will present my current state of the union, and nothing's been built yet, but I'm pretty close at this point. And then Robin can cut in and speak.
The other party can make its rebuttal.
Well, no, it's no. So all right, this is not a competition, right? These are two different designs for two different sets of requirements. Okay, that's what's important to note here, right? Is And what I find interesting is that the designs are different because we both have different needs for the end product, right? And I'll explain some of my, I guess, design requirements for the thing that I've designed, and then Robin can present, and he has a very unique set of requirements for his, right, and this drives the design process, right, and now the collaboration part is that when you talk back and forth about this, right, and I would say that some of Robin's commentary to me about what my early designs drove me in a completely different direction, right? And because I realized I wasn't considering something that I should have been considering, right? And for one, and and then you get to the point where in a design where you're liking, or it's the honeymoon period where you start to like what you've got, right? And you can see it working, and you can see how to build it, and you can see your way from the start to the end, right? In that process. That makes sense?
It makes sense to me.
It does? Okay.
Do you want to put a sketch up?
Yeah, I'm gonna pull up this is one of my early sketches, and I think I shared this particular one with, oops, what's going on here? All right, not allowing me here. So it's not allowing me here, for some reason. Okay, here we go. It might be going. Okay, so that one. Go live. I'm going to pop over to that screen. So this is what I call the chicken sketch phase. Can you guys see all that? Can you guys see that?
Yep.
You can see that?
Yep.
Some of the lines are pretty faint, and so this is an early rendition, right? And some of the design considerations that I was including at that point were, I said, well, okay, if I'm going to build this thing, right, I want it to be as useful as possible, right? And so I said, oh, well, I might want to grind something like a tool taper, that has a rather large angle on it, right? Compared to just a cylindrical shaft. So I said, okay. So I started approaching it from the sine bar principle, right? Where you're going to have a pivot, and then you're going to be able to set an angle and grind angles up to some maximum angle. And you can see, I'm asking myself questions like, what's the maximum angle? Oh, maybe 30 degrees plus or minus a couple of degrees. That covers most tool tapers, Morse tapers, things like that, right? And then, what functions am I going to need on the fixture, right? I'm going to need a fine adjust. I'm going to need a place to stack blocks, and oh gee, I need a way to kind of clamp things down so that it reduces vibration. And then over on the right is a kind of a flexure assembly that for fine tuning. And so this is kind of where I started, right? And then I had a conversation with Robin, and and he pointed out some stuff, and he said, yeah, he says, sure, you can build a sign feature into that. He says, but now you have to build the fixture really well, right? And it it's a lot of times easier just to build a fixture so that it's straight and then put it on a sign plate. And I went, ooh, that's kind of true, right? And because building it straight is a lot easier than building it straight and having a signability, right? And so I kind of took that to heart and started thinking about that. And then I started. And then he also sent me a picture of his current setup that he uses, which is and correct me if I got this wrong, Robin. It's something that you kind of put together pretty quickly that actually worked out really well that you've been using for quite a few years, right?
Yes. Yeah.
That's kind of an accurate statement, right? And so what it is basically is a bar that he clamps in a precision vise that he puts on the magnetic chuck, and then he influences the bar for fine tuning. And so all this kind of stuck in my head, and I said, "Ooh, yeah, okay, that's kind of nice." And so you can see the design is evolving. Okay, and I'm asking myself, well, what's the maximum diameter I want to be able to grind, right? Um, there's a little overhang between my rail and the actual back of the machine, right? And that's just 1.4 inches here, right, that you're seeing. So anyway, that's the next progression there. And then here it's getting a little it's changing a little bit, right? Um, in this particular shot here, I was like, well, I want to be able to influence that bar a little bit back and forth. And how do I do that? Flexures are nice and stiff, and they inherently don't have any play, and they're pretty easy to manufacture. Um, so we start to get to this, and then you're looking at the stanchions there that hold the centers, and those, and how high over the rails do I want to be, that kind of stuff. And then you start to get into what sizes of materials do I have laying around. This is the scrap box engineering. So one of my requirements was I want it to be easy to make, and I would sure like to utilize stuff that I already have that I don't have to buy, if I can. Those were one of my requirements. And then it's moving along, and centers. And then I found a little compact motor that I like the look of here for $20, and you can get a little speed controller and a power supply for this, and Bob's your uncle.
Where did you get that off of?
So that's an Amazon deal.
Gotcha.
So let me undo that one. So anyway, those are some of my design considerations and my progression in my design efforts towards mine, right? And this is with Robin's input and some of his commentary and um, the some of his insights. So I needed a different one because I needed it to be a little longer. Okay, so that was the first thing is I need more length than what the electric centers provides. And I haven't been completely satisfied with electric centers and is it's got this gigantic motor on it. It's a pain in the neck to align on the machine, and the fine adjust for tweaking in the taper on whatever you're grinding, right, is it's a clunky adjustment, and it's not a very friendly adjustment. So those are some of the things that I was trying to address. I'm not throwing away my electric centers, right? I'm building a new one that's a little bit bigger that hopefully will replace the other one, and I will only have one. Oh, and the other thing was it needed to fit on my 6x6 magnetic sign plate. That was the other one of the other requirements of mine, and it needed to be reasonably easy to build too. So, let's hold on, just give me 1 second here, and I will switch over to SolidWorks, and I'll show you what the state of the union is now. Doesn't look like sketches now. So, all right, here we go. Dun, dun, dun. SolidWorks. Let's go live. Let me shift over to that SolidWorks screen. Okay, so looks kind of like the sketches, right?
Yep.
A little bit, and with some added features here. So a couple things kind of came out when you start modeling this thing up. Okay, so let's just kind of go through it here real quick. So these are adjustable distance centers. Okay, so this slides on a linear rail, and I happened to pick up a couple of linear rails when I was at the bash for a bargain price, and so they're in the design. And in one of my conversations with Robin, I noticed that he had his motor mount, the motor that drives the article that's being ground, was attached to the magnet. And I said, "Oh wow, that's kind of a cool idea, right?" And he said, "No," he said, "it's terrible." He says, "Don't do it," right? And I went, "Oh, okay." He goes, "Yeah, it's a pain in the neck to move around, and it really makes it a pain in the, you know what, when you put the fixture on like your sign plate if you want to do something at an angle or whatever." And I went, "Oh, click, yeah, that got it, understood." So what I did was I said, "Hey, I got two of these rails. I'm just going to put my motor on the other carriage, and it can just follow. So hey, maybe I want to drive it from this end, or maybe I want to drive it from this end, right? Or hey, maybe I want to drive it in the middle." Okay, because there's some feature on the article that I'm grinding that makes for a good belt surface, right? And then this movement here, this is just for belt tension, and I can lock it in. Along those rods, and then so there's a course adjustment with there's a couple of cap screws in this area here. Okay, and this is a course adjustment. This gets you in the ballpark and gets you relatively straight. And then at this end we have a bowed flexure assembly and a very fine adjust screw.
Boy, I like that.
Yeah, that is for the final fine tuning where you're. Oops.
Control Z. Control Z.
No, it's control. Control copy, and it inserts the last part that you
Oh.
that you put in. Yeah, so I was trying to pan, but Anyway, so that's kind of the state of the union here, and this is all relatively easy stuff to build. Robin's going to talk about the importance of aligning these two centers to one another, right? Having those pointing at one another in an accurate fashion, right? Um,
I have a
and
question.
uh-huh.
How do you clamp the the sliding center? How do you put it in
So
position and then clamp it?
that's a good question. And so ideally, ideally, you want the force that's pushing those centers together to go through the exact center. Okay, that's the ideal way to do it. And so it'll be spring loaded, but my current plan is to use two small extension springs that are on that same axis and that are basically pull. Come on, slide there, Mr. Wizard. That pull these together. That makes sense.
Yep.
So imagine two small diameter extension springs that go from the fixed center to the moving center. So it applies a uniform pressure that because the shafts you can't lock them down hard, right? Because the shafts grow when they get warm when you're grinding on them, or they can't grow. So you need some compliance in that, but you need to maintain a uniform tension on it too within some limits, right? Um, and so anyway, that's the current plan right now. You wouldn't want to push along the bottom because there's a moment there. There's an offset from the base to the center that you don't want to have to deal with.
Cool.
And I suppose you could have a sliding center that's spring loaded too if you wanted to, but that makes the thing that holds the center bulkier and more massive. So at least that's my 2 cents worth there. Did you guys see all that? Me moving that, dragging the parts around? Did
Yeah,
that work okay?
that worked out
Yeah.
really
Okay.
well.
Did it? Okay. Um,
And the only hint
so,
I have for our presentation is that when you're done with the screen share, just say
mhm.
some sort of audio cue, like, and that I'm done with
I'm
that.
unsharing now.
Yeah, I'm unshare. That's right.
I'm unsharing now. Yes.
Okay.
So anyway, that's I don't know. That's not really a short story, but that's kind of how I got to where I got to. Okay. And Robin has I don't know, his story is quite a bit different, but arriving at a something similar that suits his design requirements appropriately. Right?
So
And,
should we switch over and welcome Robin?
we, yeah, we can do that. That sounds perfect.
Welcome, Robin, from the great state of
Hello.
Pennsylvania somewhere. I'm very excited to hear your side of the story and what direction you took your design in.
Well, one of the things that Tom and I discussed that applies, since this is somewhat, hopefully, being somewhat educational relative to design, is if you don't have any experience with something, pick whatever you're going to make. If you've never used one before, you have no hope of addressing all the concerns that come up because you've never used it. You don't know its shortcomings. You don't even know how it functions. So the more you've used things, most innovations that we see come from people who are into it. It doesn't matter what it is, archery, guns, you name it. Somebody who's in it that is also a manufacturer says, "Oh, I can do this. This is a sore point. I hate this, so I'm going to make one that addresses that." And the more experience you have, the more things you inherently know to even think about adding to the design. So that's one of those things that is having done a lot of cylindrical grinding and using my current rudimentary one, which does work very well, but I've been storing up all the things that that I say, oh, if I make a good one, I'm going to do this, and so a long history of that. And that's not unique to me or anybody else. It's just a matter of whether you're in the trenches and have these things that annoy you, and then they become an issue. One thing that might have not been clear on Tom's thing is not using a dog driving plate.
Yeah.
I've found in my experience that number one, a dog is a poor way to drive a part on a cylindrical grinder if you're out for crazy tolerances. If you're talking below a tenth, then a lot of these things that I'm talking about don't apply to everyday cylindrical grinding. But the reason that I'm doing these things is when you make precision spindles, the shaft diameter tolerances are 1 micron diameter total, which means your taper has to be 0. You have to have basically no, and if you have any kind of craziness going on with your centers or anything, you're in trouble. So I'm facing that all the time. So that's why these things come up. And a dog, basically, if you think about a dog, it's a crank arm. And the crank arm gets pushed around, and even if it's a pulley, it's still a crank arm moving. And there are reaction forces to any crank arm, as we all know. Wherever it is perpendicular to the crank arm is the reaction force the other direction. Just like using a torque wrench and holding the head of the torque wrench as you torque, you're supporting the reaction forces on one end, pulling with your hand on the other. Well, that reaction force pushes on the center and massages it around in an orbit. And the reason I know that is we had a grinding company that was grinding some high precision arbors that we use for making diamond rolls. And I wanted below 20 millionths of TIR on them, and they couldn't get that on a very good grinder. And I went and I looked at it and I said, yeah, that's what it is. It's the cyclic loads. So you can get around that by doing a 2-eared dog and doing a flexure mount such that the 2 ears of the drive plate can flex so that they're both applying torque evenly. Then it's pure torque. So anytime you want to use something like that, getting pure torque gets rid of those reaction loads because you're driving two opposite sides. So that's why I know about that situation. I had to go help them make a drive plate for them to get rid of that, and then they could grind that. So that's the realm of the stuff that's involved on why I'm making a new one. The other thing is I might have 6 shafts to grind, all different lengths, and cleaning off whatever your adjustment system is. And then having, now that I've adjusted it, it's not grinding perfectly straight anymore. That's a pain in the neck. Yeah, and I don't want to have to unbolt something and move it because in my world, that is a nuisance. So there's a whole ton of things like that add up to where my current design is. And what I have on SolidWorks, I actually have the actual body of it done. Everything's not completed yet, but it's certainly done enough to see what's going on there. The first thing I'm going to show in SolidWorks is just a quick analysis of centers. 60-degree centers are good, but they are a can of worms when you get below a tenth, because any difference in the cone angle of your centers, if your cone angles aren't exactly the same on both ends, if they're not pointing exactly at each other, if your centers in the part aren't perfectly coaxial, if one's pointing at an angle, you can end up where in one orientation the center is actually bearing on the very smallest diameter of the cone in the part. On the other end, it's bearing on the opposite. You grind your part and you check the TIR, it's beautiful. It's as good as your indicator can read. You flip the part around and it's crap. And it's because now that's not running on those contact points anymore. They have changed because everything isn't perfect. So that's the reason there's the alignment of your centers in the grind fixture only influences taper. The alignment of your centers in the part will affect the run out. each end of the part. So we're not going to go into the weeds with that, but basically that's why those things are really important. That is why spherical centers are very good. As long as they're the same size, you can flip apart, do whatever you want, and you're not going to have any troubles whatsoever. You can use whatever adjustment method you want, and not an issue because you have a line contact of a sphere and a cone, and you're good to go. Another thing that is assumed that you shouldn't assume is if your centers aren't actually round. If you have a center that's even 50 millionths, not truly round, and we're talking about in the part center, that part will actually wobble that 50 millionths. And you can end up with a part that's 50 millionths out of round because of it not actually seating a true kinematic seat, which would be three individual pads in that center. So sometimes it pays to, one thing I do pretty much all the time is I take a tool and go in and grind 3 relief grooves in the center, evenly spaced. Eyeball is good enough. 2 things it does. It makes it a 3-point contact so that it is an actual kinematic mount, or a kinematic situation. And it gives a place for the lubricant to get into the interface, because centers tend to just dry up, and no matter how much you have on the outside, it's wiped away. So having grooves where that can carry in and keep feeding is a big deal.
Now, just clarify, you're talking about grooves in the male center.
Conical face.
On the
yes, in the female center of the part.
Okay, so you basically you've created a center, then you go in and you put groove.
Right. I'm talking about just taking like a diamond mandrel after it's heat treated and going in there, putting some Sharpie marks to keep you straight, and just going in there and putting a little relief that might be 5-10 thousandths deep, has a nice gradual blend out, and then that's where the lubrication can wick into that in all 3 places and keep that thing lubricated.
So these are grooves along the cone in the axial direction.
Yep.
Okay.
Yep.
So it's like I got it. So yep. as the part is moving on its fixed center, that groove is moving around and is allowing a place for the lubricant.
Yeah. And then the other assumption that you shouldn't make if you're out to kill is that your center is actually round. So you need to have a smoking setup for grinding your centers round if you're out to kill. And that it's always good to know the extremes and back up from them for all the other work. But knowing what can bite you in the butt can be the difference between people saying I have no idea what's going on and saying, oh, I know exactly what's going on, and it's a big help. So I'm gonna share my SolidWorks screen here. Let me get it up here. And I'll start out with the centers. There it is. I'm going to share my screen first here. Wrong one. There we go. Share screen. Applications. I need.
We're doing it live, folks. This is live.
Yeah, I'm looking for my. Can I hit my SolidWorks screen down here? And no, that's not good.
When you go to share, Robin, you usually have some choices on the share screen. So.
Yeah, it didn't have anything but the Discord. Let me actually. I'm gonna get out of here and make my SolidWorks not full screen, and then I'll be able to see the Discord at the bottom to share the screen, and that'll probably let me do that. There we go. That's what I needed. Go live.
So Stefan commented, first of all, he says hi. He commented, Robin just described the very problem I encountered with my center set. The drive dog is a huge liability.
Amen.
We have your screen.
There we go. So actually, I think that's on there. So I can go to my actual SolidWorks screen so I can see what I'm doing. I think. Tell me if I lose you. I'm gonna maximize this. It's still good there?
Still good.
Okay. So what you're seeing here, I'm going to go to I have configuration so I can quickly change between this. All right, this is 60-degree centers in perfect 60-degree holes, perfectly aligned. The centers in the part are perfectly aligned, and the centers themselves of the grinding fixture are perfectly pointing each other. Now I'm going to go over here to this is a 2-degree tilt of the right-hand center, is all I'm doing. Okay, and now we'll come here and we'll look at this, and you can now see that there's a contact point here. Can you see the mouse where I am?
Yeah, we're getting
okay.
a little flickering, but it's okay.
Okay. There's the contact point here, and here's the contact point here, just because of that 2 degrees on the opposite end. Now we'll go over here to this end. That's the 2-degree end, and now you can really see the problem. You're contacting here and here, and what that means is you have quite a gap laterally in and out of the screen. There's plenty of room for that center to move. So if you're going to have this situation, you'll notice on the Atco grinder, they actually tilt their center up and down like this for adjustment.
Yeah.
You can get away with that because it's going to be reasonably stable in that orientation. It's going to fluctuate in and out sideways, which isn't, when you're grinding on top, which you are in the surface grinder, that isn't really an issue. But that gives you an idea of what goes on there. And then you can take all the different things of angle and all that, the actual match of the angles on the male centers and the female centers. So one good thing that I'm not sure how many people are aware of a ring seat
center drill.
Yeah. Okay, and basically there are curves. They're a center drill. It just drills a hole just like this, nice arc, and this gives you line contact over quite a range of angles, and that gets rid of a lot of problems. They work really well. You still need to lap your centers when they come back from heat treat, because, like I said, the roundness of the center and it can affect your grinding. But ring seat centers are quite a help there. I don't have this where it functions properly because it won't make the arc there to the cone properly. But you get the idea. So I just wanted to point that out that when you when you make a center setup, one thing that's important is engineer a way to make sure that these centers point at each other. Okay, now I'm going to go to the assembly of the actual grind centers. So one of the things that I wanted to do is, let me get right here. This is a high-speed steel planer blade that's been bonded to the main body of this, and it has been ground perfectly straight to the seat that was ground for the linear rail. And the premise here is I don't want any chance of linear rail inaccuracies affecting what I'm doing. So I can grind and lap this to be perfectly straight. And what happens here, all this linear rail does is guide this thing along, okay? And this is my loading system here that's not letting me go further than that at the moment. One thing you'll notice down here at the bottom, if you're familiar with Freshetta V-ring seals, these are 2 little mini ones, and they are, here, let me just isolate this. And we can look at these, and you see there's a post here, and then this little rubber seal just goes on, but this squeegees off all the crud.
Yeah, it's just a
So
scraper.
these are meant for rotary use, but I chose to use them in this mode. So this is the actual bearing area, metal to metal. These will probably be bronze posts that are inserted here, but there'll be tweaks just so that the linear rail system's putting a light loading on these feet to do that. I was thinking of a simple way to do that, and I thought, use 2 of these, and that's plenty of bearing area. This looks frail. Yeah, this looks frail, but what Tom was talking about in the loading system, this is basically like a clamp, like a regular, pony clamp or whatever you want to call this style.
Bar clamp, yeah.
Yeah, bar clamp. But the key here is, let's look at this interface here. I'm going to isolate these right here. Okay, and now I'm going to make this transparent. Now you notice that that's actually like a tooling ball, and that tooling ball goes in the hole, so it's not influencing at all whatever angles this thing bows in the process of putting force on the centers, and it's darn near right in line with the centers. So it's basically as close as you can get to an optimum system there for applying the loads at where they're needed, not creating moment bending in the whole rest of the system.
That's neat.
This is not fleshed out yet. I threw this together to give you guys the concept. This bar will pretty much look like this, but this needs a loading method which is adjustable for pressure. It also needs a lever handle that I can just squeeze to retract it to get the parts in and out. And then another very important thing is it needs a non-influencing clamp that I can turn on, that wherever it is, when I need to do a face grind, which 99% of the time is pushing the part towards me, towards the screen, spring loaded, you can actually just unload and not have a grind. This needs to be rigid, get a flat grind. So you lock the disc brake, if you want to call it that, do your face grind and release it and let it go.
That's a good point. Yeah.
Now these are replaceable. I have different configurations of these. This is for the 3/8 diameter. If I need something bigger than that, I will put an enlarged head on these, but I have versions of these that are down to 3/16 diameter, so that the amount of clearance over the wheel is, if I need to get close. These actually, I'm going to turn on transparency here. This is an actual angled bolt that seats this, but the actual clamp screws also seated in there that actually clamp the feet here. Functionally, relative to how this is made, that's one of the things that's very important, especially for your home use, is making sure that the equipment you have, you can do your best. So these pieces, the head block and the tail block, they can go on a piece of lapped carbide, put them in V blocks, and I can grind both mounting faces so they're dead true to these centers. It's not important the exact value, it's important that they're dead parallel to each other. So then these are replaceable. In the same way, when I have this all lined up with the rails and all this, I can lock this in place and I can grind these seats on both head and tail and the face that's dead true to all the axes, and then that makes sure that everything's pointing at it themselves exactly.
Neat.
This is made out of 1x3 tubing here, and same thing here. But if you design very many fixtures, after a while you say, you know what, if I had half a brain, I would make things slope surfaces so that the water runs off in a direction that I don't have to deal with pools. So this is slanted. Let me get here. I'm probably driving you guys crazy here. But you can see there's a slant in this downhill. Just get lined up here.
I saw your drain hole.
Yeah. And keep in mind, guys, this is hours and hours and hours of just pondering when I'm not nothing else to do. My wife's watching TV or whatever. I'm sitting here just thinking about. So I might have thoughts on some of these things for 4 or 5 hours, not necessarily all together, but because I'm not in a rush. And that's where you start nitpicking yourself and saying, oh, well, what about this? What about that? Oh, I don't like this. It's too clunky, and you improve things. So here we are. This is tapered downhill this way, and then in this view, this is running downhill this way to the left, and then there's a drain hole there so that everything can get out and drain out the back.
You're pivoting your motor mount for belt tension, right? Is that what you're doing?
Yes, and then this is a piece of just case hardened rod, and this is just pinched completely. But this motor, something similar to what you're doing there, will go in here, and I'm just going to let that pivot for the sweep, and then the adjustment is just in and out on the rod.
You can run it in and out. It's very similar. Yeah. Mm-hmm. Nice.
And what else? Oh, the right here is a flexure that is the main pivot, right, for the whole thing pivoting from here.
Can you zoom? Can you zoom way in? Can you zoom way into your flexure? There we go.
There's the flexure, and then these are two just carbide strips that are brazed on that I can lap for this to be dead perpendicular to the axis of the grinder, so that when I put it up against my reference rail, and my grinder spindle has been aligned so that it's square to the grinder rail, to the X travel. When I put this in and stuck it up tight to the rail and go to do a face grind, I'm going to get a darn near perfect crosshatch, which is important. The crosshatch is a sign of alignment in at least one axis. You can still have dished parts with a perfect crosshatch, but at least it's uniform and grinding in one direction. So here's at the end of the 6 inches. This right here, this is the surface that's going to sit on the magnetic chuck, and it's 6 inches wide, so it fits on the 6-inch sign plate if I need to.
What material did you choose there?
This is just mild steel. This is just low carbon.
Yeah.
But here's where
I
my
consider cast iron for that, since it releases so nicely off the chuck.
That's true. Yeah, I might even take you up on that because the less residual magnetism in it. Yeah.
I like the 2 points against the rail. I considered some bumps there, but I'm going to think about that one a little bit. Yeah. Nice.
So go ahead, Tom.
No, that was it. I was just complimenting you.
Okay. Thank you.
I'm happy to stop, but
these ends obviously get capped. They're just I actually have these pieces made, but these ends get capped. They're just there for construction purposes at the moment. My adjustment for taper, which, like Tom said, this is just for a very small range. I'm not sure what I'm doing there yet. I don't want to have to remove the part to adjust it.
yeah,
It needs to be technically over here as close to this where the forces or down forces are as possible. But I'm trying to keep the overall height of this thing low.
exactly. Yeah, it's hard to get a real
Right.
low profile fine
Yeah.
adjust in there. Yeah.
Yeah. And then you also have to keep in mind, you notice here I've got something that's got some significant vertical depth, so that this rail is relatively rigid. If I just stuck this on the end of this 1 inch, it would be relatively flimsy. So that's why I have this piece. These are all actually welded together. But in order to do that, I had to overhang it and go back and still keep the wide stance at the back. And none of this is saying this is perfect by any stretch of the imagination, but it's where I'm at the moment. So the adjuster needs to be close to here. I might just use a very large radius on a fine thread with an actual hex on it, where I just reach in underneath here with a wrench and tweak that. I'll put Belleville springs that load it down against that on both either side of that, and just push it up or down relative to the Belleville springs and have it good and solid. Because that's basically what I do now with just a screw in my rail of my current grinder, pressing on a hardened piece of tool bit that's on the chuck, and watching the response on a 50 millionths best test.
Yeah. Do you have a picture of that for reference? Because that picture that you sent me influenced me considerably, right? That methodology.
I have it on my phone. Yeah, I'll probably come back to that when you get back on. I'll find it, and then rather than waste time here I got to send it from my phone to my computer.
Yeah, okay, no problem.
One thing that I want to build in is when you're trying to adjust taper to be virtually zero, you pretty much have to measure on the part what the actual movement is. And that works real well, but I'm kind of thinking I have a jig borer style of 50 millionths best test. I'm actually thinking of plunking a hole in this and because I want the actual reading to be as close to this as possible, but I don't want it in the grind zone relative to coolant and all that. So I'm actually thinking of cutting a hole in this, putting a post in here and letting that best test reach in here and be permanently mounted in this, where I actually read the up and down directly out on this face where it's protected. So that would be pretty cool.
Yeah. Just leave it on there, right? Because
Yeah,
it's
just
just a
leave it on.
relative movement, right?
Yep.
Is all it is.
Yep. Maybe make a little twist lock 3D printed cap that goes on that covers it when you're not using it, so it's actually watertight. Yeah, so just lots of little details like that. I think that covers pretty much, and we already discussed the whole idea of using belts. I actually turn up a whole bunch of like 2-inch PET with a groove in them. I mean, they're only maybe a 1/4 inch wide. I put a groove in them for like a 5/32 urethane belt or urethane round belt, and I drill and tap them all the way down to like a 1/4 inch center hole, M3 for an M3 or excuse me M4 set screw. And I just have a whole bunch of those. And whenever I have something, I just put it in the lathe. I bore a hole in it for size I want. I mark that size on it, and then it goes in my driver drawer, and that's what I use to drive shafts. And you end up with a whole bunch of those that fit 99% of what you do, and that works really good. And some parts you just drive right on the OD of the shaft. If it's a large enough diameter, there's typically enough traction to just drive right on the shaft.
Yeah, the urethane's pretty grippy. It works pretty good.
Yep.
So.
Yeah. So that's
Nice.
pretty much it. I'm not sure. And obviously, both in Tom's instance and mine, once you have this thing grinding straight, then you're confident to just take it as is, put it on the sign plate, and you're as good as whatever the sign plate is as far as the angle you're grinding. Yeah. And if you need to tweak it, and you have some other external method you're using other than just trusting the sign plate, you can make those tweaks still sitting on the sign plate. So that just makes that work well. But this bar principle here, I've used this. I've done a lot of fixturing where fixture deflection from clamping is an issue. And I've made a lot of fixtures where basically I've made a really fancy floating clamp that surrounds the part such that the fixture does not move when you clamp, because all the clamping forces and distortions only happen in the clamp body, which is floating. And so that's a powerful design thing for precision fixtures.
Wow.
That's it.
Nice.
I have a question.
One other point that I mentioned, I knew there was something I was forgetting, and that is this rail is up here out of the way so that the actual grinding action that occurs, all this stuff's getting thrown out here. There will be some kind of cover on this besides that. I don't know whether I'm going to do something telescope.
You're in a different window or something, Robin. You're not dynamic on the SolidWorks right now. So.
Is it? Can you see it now?
No, not yet.
So, did you minimize your SolidWorks?
Nope, I didn't touch anything. Let me shrink my screen here and see if I'm still. Yeah, it still says I'm streaming.
Yeah, we're not getting a live update here. So, why don't you unshare for a second and then come back?
Okay.
Confirming that you unshared.
Yes. And then go back to your SolidWorks window. Yeah, I had a message that said he had minimized it. So, okay, this looks better.
There we go.
Okay.
Yeah, don't do any minimizing or maximizing.
I only minimized that to turn it off. I had not actually minimized the screen.
Okay.
But you can see that the rail here is up.
The linear rail? Is that what you're referring to?
Yeah, the linear rail is up in the air and away from the grind zone. Mm-hmm. That's why I put this hardened rail and the squeegee system on the feet, so that did the accuracy, but this rail is only really just guiding things along, but can be covered and basically stay out of the mud. Mm-hmm. That's it.
Pretty cool. So I like your idea of the square tubes, the square tube welded, weldment for your structure.
I stopped streaming. I'll go grab those pieces in a second.
Okay. Well, pretty neat. So, Tom, do you ever use the bell-shaped center drills for your centers?
Yeah, I have some of those, and I've used them in the past. Originally, I was going to use spherical centers because it eliminates a lot of the problems. Because sometimes you don't have the option of modifying centers that you're given. And Robin points out that lapping your center for before grinding is important too, and that's a whole nother podcast there talking about that stuff. And,
Which we should do.
sure, yeah.
Robin's
Talk
back.
about that.
Here's the section that actually is the bottom piece that has the taper in it. But you'll notice inside I've put posts in this to stiffen this. There you go.
Oh yeah, I see them. Yeah,
Good
Little
shot.
quarter inch
They're
ones.
actually through, and then they're completely welded on the outside and ground off to stiffen that section, so that this gives us a little bit stiffer
Is
body.
that stainless or steel?
Steel.
Yeah.
This is the main rail setup. So this is all done as far as that stuff. It needs to be ground. This has the stiffener posts in the center also, and then this has the end where the screws that fasten the tail piece will go on. This is the piece that the hardened planer
it's
blade
blue
goes
too?
on. Yeah. I'm actually probably going to solder that on with like Stay Bright.
Oh, okay.
Yeah,
Low temp. Yeah.
Yeah, the low temp stuff, because that's plenty good enough for that to stay put. So that's that, and then this obviously this will get welded to this permanently at that angle, running downhill, and that's about it. Like, these are all the blocks ready to go that will turn into those center holders in the various configurations.
Pretty neat.
Nice.
And
Well, he's farther along
these are
in the construction. Yes.
Yeah, these are the cute little
Oh, wipers. Yeah.
the cute little Freshetta seals that go on there. Another tip is, if you have a lot of grinding to do, I have done things where I've used these on the centers so that this actually rides on the outside of the center and goes up on the shaft and keeps everything out of the lube.
Oh, shields it. Yeah.
Yeah, it shields it, so I can go on and do a really nice job.
Can you get us a pointer to those? Is that a McMaster car part or?
McMaster does have them. If you go under seals and just keep looking for that, or SKF, I think is who handles them now. Freshetta, I think, was the original manufacturer of those when I first started using them ages ago, and I'm sure SKF just sucked them up, and now SKF is who they come from. But yes, McMaster has those, and they have them in Viton, which I strongly suggest.
Very
If you're using
interesting.
coolant.
Hey, we have a question coming in from Almost Machining. He says, I've always accepted it, but is there an acceptable wear band or part failure at center contact? I've seen centers and parts ruined at the center's location, or did I wander too far into the deep end? Leaded lube gets harder to get, he says.
Well, that
Good.
I don't think too many people are using white lead on centers anymore. Everybody's using that
Molly?
CMD. CMD. What is? It comes in the
CMD
yellow.
number 3. Yeah,
CMD number 3.
Extreme.
A super high pressure lube. It's like I don't know, thicker than honey, and pretty tenacious stuff. So
And no
works
lead.
pretty good.
And no lead.
The magic bullet there is buying
Boron nitride. Yeah.
boron nitride powder and mixing it in. So I load my CMD lube. I actually warm it up so you can stir it in easier. And I put probably an equal volume of boron nitride powder in. Stir that in, and boron nitride is basically white graphite or white molybdenum disulfide. And
We use it on heat treating fixtures on the fasteners and heat treating fixtures to make it so you can take it apart.
Yep. And there's also spray, ZYP company, ZYP. They sell spray. It's expensive, but like if you want to mask something so that silver solder doesn't stick or whatever, the stuff's, I don't think there's any temperatures that even bother it. People use it on, glass molds and all that. But the problem with the powder is you have to buy a kilogram or something, and it's pretty expensive for the average hobbyist to buy a bag of it.
Well, if it would help, we could buy the white powder in large quantities and then package it in small quantities and put it, out for distribution. Wait a minute.
Sounds like something right up your alley.
I was just going to say, did I just describe a different kind of business?
I think you just had a catalog item for PFG. So.
Yeah. It's not a bad idea.
To answer the question is I never use anything but carbide centers. And I don't just grind them. I grind them and then I lap them so that the surface finish on them is extremely smooth. And I grind, lots and lots of shafts before you can even tell that anything happened to the carbide centers. So I just never even bother with. I realize that you can't always do that, but yeah, I just don't grind with anything but carbide.
You just lap them with a little cast iron cone lap or whatever. Yeah.
I just lap them after they've been ground well on
with a flat stick lapper.
I just use a flat cast iron piece and some 3 micron and just go at it until you can't tell that there's any, and then if you want to get fancy, you can use a piece of wood then with the same 3 micron and make it blow your eyes out with the reflection. And but.
So
nice.
One of the things I've heard you say recently, Robin, was dropping down to 1 micron or even finer. You don't feel there's a place for that. You seem to be going to a softer substrate for the lapping material as you get finer and finer. Am I reading that correctly?
In some cases, yes. Especially on like when I'm lapping the ceramic lap that I lap my tools with. I basically use 3 micron period on there, and the trick there is you use the 3 micron. I use a little acid brush. I dip it in 3 micron slurry. I only squirt enough in I have it in a squirt bottle so I can shake it to get it, uniform. Put a couple squirts in the bottom. Then I take my acid brush it on the lap while I'm lapping so that I keep the stuff engaged. Otherwise, it just rolls up on the tool and, goes nowhere. But once you're done with that, then you wipe the lap off and let just a smut build up. You go and you start lapping and it's still cutting, but then those particles are breaking down, and then you just get this black sludge that's on there, and that's what gives you just like a mirror finish. You're basically taking that 3 micron, turning it into something else. Right. It's either floating on the sludge or whatever, but you get a crazy good finish without switching gears and using a different thing.
Let's see. We got a Castra says. We just lapped a 600 millimeter piece of stainless steel based on Tom's method, and we got it to better than 1.5 micron flatness across the length of the bar. Thanks for the tips, Tom.
Awesome.
Okay, good.
It's nice to hear.
I don't know what I said, but I'm glad it worked.
Pretty cool. And so I'm intrigued by sometimes you don't have a choice. Your parts have a 60-degree center, or you're just locked into a 60-degree center on your setup. But if you could rewrite the book on centers, would we ditch the 60-degree center and just have something like a bell-shaped hole in a spherical ball? Or, what would be the ideal setup? We'll go with Tom first.
I don't know. There's this balance between ease of manufacture and results, right? So as Robin pointed out, right, the fussier the finished product, the more everything matters, right? So for the great bulk of the work that's done out there, 60-degree centers, with a center drill are completely adequate, right? And now when you're grinding to sub-micron kind of tolerances, you have to look at everything, right? And in Robin's famous words, the whole world is rubber at that level, right? So everything affects everything else. So you're just eliminating sources of error, and or reducing sources of error, I should say, not eliminating. You never eliminate them. So that's really where that stuff comes in. And honestly, those curved center drills they're not super easy to find, right? If you go on MSC, they're you got to dig to find them, right? And then when you order one, a regular bell type shows up, a 60 degree, right? So because somebody didn't look in the box when they threw it in the bin, right? So that's been my experience. So I don't use mine. I have those kind of squirreled away in a different area, right? And you only use those for kind of special occasions, right? Party centers. So.
Yeah.
What do you?
You have to be careful with the actual amount of weight that the centers have to hold.
Mm-hmm.
Everything I'm typically doing is, lightweight by comparison to what a lot of people do. So you have to, if you take a spherical center in steel, even hardened steel or even carbide, and throw a 80-pound part on it, you're going to have trouble because you basically have a line contact, and those weights are enough to deform it. And now the answer to help that is use silicon nitride, because silicon nitride has no affinity for any of the materials you're going to be grinding. There's nothing that it can weld to. It cannot.
Right.
It can't bond to the silicon nitride, where everything else can just weld up and go, including carbide.
Mm-hmm.
But that's the issue with a ball center.
Okay, let's clarify this, because I think you went pretty fast. So we have a center in a part, and you're saying that if you're going to stick a ball center in there, so a ball center on your fixture, that ball wants to be silicon carbide. So he said?
Silicon nitride.
I'm sorry, silicon nitride.
Yeah.
And that's to prevent galling, metal on metal. And I don't know if I'm even familiar with silicon nitride. They come as balls, or?
Yeah, so
absolutely.
Yeah. When they talk about ceramic bearings, these are the kind of balls that are in the bearings. And high speed, high precision applications, and high temperature too, I think. So
yeah.
And it won't gall on steel. That's very interesting.
Right. Well, two reasons. Number one, they get ridiculously low surface finishes on the silicon nitride. So that in itself is one thing. But then again, even the asperities that do come in contact and would cause normal welding and frictional things going on, it's so that's pretty much eliminated by the fact that there's no affinity for it to actually bond together.
Pretty cool.
So I have a 60-degree center story, if you guys want to hear that.
Oh, yes.
So Robin mentioned load bearing. And if you think about a ball in a cone seat, right? You got a curve meeting a conical surface, right? So the what do you want to call it? The upsetting force. It has a natural ramp that wants to would allow it to ramp out. So one of my mentors, he's long dead at this point, but he told me a story. He worked in the naval shipyard in Bremerton, Washington during World War II, and he was running a large lathe, and that could be a pretty good sized lathe in that shop, but anyway, he was doing a shaft, and he whistled for the crane to come over. He was done with the shaft. He whistled for the crane to come over to take the shaft out of the lathe. So the shaft is too big to pick up by hand, right? And apparently, I guess there was a new crane operator, and it happened to be a female crane operator. So he whistled for the crane to come over, and she drops the hook down over the lathe. He rigs it up, and then gives her a signal to take up on it a little bit, to just take a load so that he could back the center out of the lathe. Well, she got a little rambunctious and hit up too hard, and actually lifted the entire lathe off of the floor and ripped out the electrical for the machine. So
That's bad, right?
yeah, not cool. And but it also illustrates how studly a 60-degree center is, right? And now, I'm guessing this was a pretty robust. We're not talking about a number 2 center drill, drilled halfway in or whatever, right? And he didn't tell me that part, but so anyway, he calmly tells her to lower it down, and they get things squared away, right? And he said, "No, you're only supposed to take tension on the slings, right?"
So yeah, priority one was to save the part, right?
Yeah, no, get the lathe back on the floor. So
well, right after that, I mean, you want to get, if the part's done and it's World War II, you want to get that thing moving down the road.
Yeah, he went on to tell me that he talked to her a little bit and encouraged her to not do what the other crane operators. So these are old school cranes where the operator rode in a cab up on the crane, right? They weren't controlled from the floor. So there was an operator up there, and when you needed the crane, they brought it over and did the thing. But she started practicing at lunchtime, apparently, and he would put a bucket of scrap metal with the handle bale up, and then take a running start from the other end and snag the bucket going by it and lift it up and then deposit it somewhere else. So she got really, really good at it. So the
Wow.
end result of the of the thing. Anyway, that's a funny little story. So.
I like it.
But,
On the ball centers, there is a way to use spherical centers that eliminates some of that problem. And those arbors that I described previously, where the problem with the dog driving was brought to light, those were arbors that we were making for internal use for when you make diamond rolls. There's all different mounting diameters that people use, and you have an arbor that's about 6 inches long, tapered about 4/10 over the entire length, and you use the CMD extreme pressure lube. You put it on the shaft, you push your very precise bore of your diamond roll on there, and then all the fine tuning on the diamond roll that you're doing, lapping or grinding the diamond surface to get certain accuracies. You're doing that on all these various machines. So I bought grade 5 half-inch balls and made these arbors where they had basically a press fit for the ball and a bottom that you could press in, and then they had a cross hole where you took a wedge, kind of like a drift for Morse taper, to kick the ball out once the ball was shot.
Warm? Yeah. Okay.
But that way you wouldn't lose your accuracy of your arbor, the run out accuracy of that. Now I was using steel balls, but in all of our fixtures, I actually made a little puck, about maybe 3/4 inch diameter puck, about 3/8 deep, and then used Mogliese to mold the perfect match to those balls right on a ball.
Mm.
Put oil grooves in the Mogliese. After it's cured, take it out, relieve the back so that the contact zone was appropriate for being, the equivalent of a 60-degree center, and use the Frechetta seal on there. And that gave you a perfect ball center that had huge contact area. It had a perfectly mating spherical pocket because it was molded. Mogliese is for those who don't know, it's a epoxy way lining material intended for either repairing or actually building from scratch intentionally a good sliding bearing surface. So that's what that was in there. So those work very well.
Pretty cool. Mark Span says, "Hey, Robin and Tom, for some of us newer folks, a video on making and lapping carbide centers would be helpful. Carbide centers 101." And Matt chimed in as agreeing. Is that a separate video?
That's difficult. Tapers of any kind are not something that you have inherent self-accurizing. You do as far as roundness at any particular spot, but without the ability to move axially and have different areas going, the lap's just going to wear to whatever the taper of the existing thing is, and the roundness could improve some, but it's very hard to not end up with just a very grooved thing when the lap can't translate and change its orientation and get various sections interchanging back and forth like cylindrical lapping would be.
Yeah, the error.
Tom might have some magic there, but that's tough.
No, I've always done them with a stick lap, right? And in fact, I generally grind them on the decal because it's convenient, right? And but that's not necessarily very round in comparison to some other fixture, right?
So when you say you use a stick, give us a little more detail on that.
Something that looks like it's just a rectangular piece of cast iron or copper or bronze or whatever, depending on what you're lapping, right? That you charge with diamond and then use that as your lap, right? So it looks like a file basically, but it's smooth and you charge with diamond. So does that make sense?
With carbide, you can just take, like, if you have 1/8 by 3/8 cold rolled steel sitting on the shelf. I just whack off a piece. I go over to the magic sanding plate, stroke on there until I got a nice uniform shape. Now I go basically on a 45-degree angle, so I know I'm getting the flatness reasonably good. Clean it off good, like Tom said. Charge it with some diamond and go to town. But you renew it frequently, because when you do that, you'll look at it and you'll say, okay, I'll go take a look, and you take one stroke on the magic sanding plate and you say, wow, there's already a hole in the center of that thing.
Exactly.
And
right.
So very important to keep going back and re-establishing the lap being flat as you're doing the centers. But the zero spindles that I had shown on Instagram, the ones I got at the auction, those have super good, they're typically less than 20 millionths TIR. So I'm looking forward to tweaking those up to use for grinding centers where you've got a really good, you have to have an accurate means rotation, of doing that. Mm-hmm. Yeah, rotation.
That's the key, is the rotation has to be real accurate. And so you use your best tool that you have and then lap and, it's a Hail Mary at that point, right? So But once again, it all depends what kinds of tolerances you're trying to achieve, right? If you're trying to get down into micro inch run out and stuff like that, all that stuff makes a difference, right? If you're happy with a tenth or two, pretty straightforward.
So I will say, go ahead, Spencer.
No, pick it up, Robin.
One thing that Tom and I have discussed, and I think both of us have probably mentioned before, is if you're, number one, you won't always get the opportunities to increase your skills with the place you work. And if you have your own shop and you're trying to increase your skills, you need to invent things to do these things and get the experience and say, oh, okay, now, if somebody asked me to lap something now, I'd have a clue and I'd actually be pretty confident, cylindrical lapping, whatever. And and the going beyond what is necessary, once you've got confidence level at that, backing up is easy.
That's right.
And you learn a lot. You learn a lot in the process. I mentioned to Tom the rotary spin grinding thing that I showed on Instagram. That whole progression of making these. I made two for a customer, one for myself at the same time, and ended up having to lap the rollers individually, making a thing for cylindrical, lapping the rollers to get them more uniform, and get down to where I have about 3 million facial TIR. And
That
you'd
he's still
say
not
like,
happy
well,
with, by the way.
yeah, still not happy. Yeah. And that might be like, well, that's stupid. No, it's not stupid, because I have customers who ask me to do things where we're talking about half micron tolerances on run out, and on like grinding wheels, CBN grinding wheels, where I grind the hub and the wheel, and they have to be that close. And they may come back and say, oh, you know what? That you need to take 1 micron off that grinding surface. So I put the wheel back, come down, actually be able to touch, and put it and touch down and actually do that. So that comes like to the Harrig. Well, you put 5 millionths resolution on the Harrig and a means of it repeating and being very consistent. Well, that doesn't even faze me. I can move in 5 millionths increments and wait for the Sharpie to start to partially disappear, 70% disappear, and do that. So those are examples of, if you're interested in this stuff and you want to get better, go to the extreme. Push it as far as you can, and then those things will come back, and it would be that much more valuable wherever you're working, because you've got tools in your pocket that everybody doesn't have.
Outstanding advice. Thank you, Robin. I just got a thing in house where I've got to do some lapping, flat lapping, to a very high degree, and I'm taking careful notes of everything you've taught, and I might be ringing your phone to make sure I'm doing it right.
Yeah, right.
So you guys are continuing to build your rotary fixtures, and I'm looking forward to progress and results. This is pretty cool. I know I have one of the it's a Harrig electric center, and I know Solid Rock Machine did a little thing on going to spherical centers on that. I think he made a couple of special centers, and that kind of had me intrigued. But things that can improve that thing a little bit, improve that rig a little bit, are of interest, even if I don't design a whole new one. But a lot of good points.
So the other thing I was going to throw out here too is this. Robin and I are both very keen and interested in the kind of creative process of design, right? Mechanical design. It's something that I certainly enjoy doing, and I think Robin does too, right? And is attacking these problems and coming up with solutions, and then eventually building them, and then and in my case, usually when I build them, I'm and it works, I'm done, and I move on to something else, right? And but that whole process is of interest, right? And for people that don't necessarily do that for a living. So one of the things that and we use this example of this cylindrical grinding fixture as a way to kind of break the ice on the subject. So Spencer, I was going to mention that what we're thinking about for the future maybe is a random problem, right?
Yep.
And so one of the things we're thinking about, and we want some feedback from the audience here on whether they like that idea or not, is for us to do this kind of cold turkey, right? Where we're presented with a particular design problem, and could be anything, and we kind of attack that problem on cold turkey, and you guys witness that process, right? And I guess is what ultimately we were thinking about might be cool entertainment. So I'd like to hear some feedback if people have any thoughts on that.
So if anybody does have feedback on that, a good place for that is the comments section of this video, because everybody has access to that. And on Discord, you can put it in the chat of the live stage, and we'll kind of collect that information and feed it to Robin and Tom. I think it's a great idea. Starting
So
from a
we're
white
not
sheet.
looking for suggestions right at this point, right? So the way that I would envision something like that going down is that Spencer might solicit a handful of ideas, right? And then choose one. And I think the key element there is that we don't know what it is coming in, right? Because I know what my brain would do is if I even get a hint of what the problem is, it's going to start working on it immediately, right? And it's
Unavoidably.
not going to be, yeah,
Yeah.
it's not going to be that we're going to come in loaded for bear, right? And so
All
yeah,
right.
it's
Well, we'll get some feedback on the concept from people, and then when the time is appropriate, we'll put out the word and we'll say, okay, we're soliciting ideas for a date in the future, and then we'll do that. And we're learning a lot right now, right, in terms of technical issues, and we'll apply the knowledge we're learning today on the future mission. I think it's a great idea. It's gonna be super.
well. I hope you guys enjoyed this because I certainly had fun talking with Robin and thinking about this from a design aspect, right? And yeah, thanks for letting us
Same
share.
here.
Well, thank
Yeah.
you guys. You're both masters of your craft, and by that I mean you acknowledge that you're continually students, and that's just awesome. So thank you very
Well,
much for
I,
sharing.
that's
I,
really a key element there is and we hire a lot of mechanical technicians and engineers and things like that at work, and that's certainly one of the traits that I look for is it's somebody that has that spark of curiosity, right? They want to know how things work. They're interested in many different things, and they apply these different areas to their work. And it's an important trait to be a, uh, a lifelong student, right? And there's if you look through the history of the Industrial Revolution, right, there are some incredibly smart folks in there, right, and you know functionally we are just reapplying some of their ideas in a different way, right, and there are no new mechanisms really, right? It's just applications of those on new problems, right? So having
I,
a big
I,
library in your head is, or at your fingertips, whatever you want to say, is an important part of it. So.
I'd like to thank Tom. Many probably wouldn't don't realize that the reason I'm on social media at all, YouTube, Instagram, the whole thing, is from one of his videos that I watched where he mentioned about feeling an obligation for a occupation that's been so good to him to share back, and that struck a note with me, and that's the whole reason that I'm on any of this. And really been enriched just having the feedback from both YouTube and Instagram and friends that we've Tom and I didn't even know each other before that.
Yeah,
Um,
and it
and
it was super unlikely we would have ever met, right?
yep, exactly. And the other thing that Tom would say this exact same thing himself, and I think he even mentioned it on that same video, was he and I are not the greatest guys on earth. There are tons of people that are smarter and do way past what we do that just aren't. You just don't know about them.
Right.
So we don't think we know it all. We just have fun doing this, and there's lots of people out there that are way past what we're doing.
Yeah. I mentioned this mentor of mine that had the lathe ripped out of the floor, right? And you know, I tried to get him to. I wanted to buy him a computer just so he could see this emerging internet, right? And all these people that were there was forums being created at the time, on things that were of deep interest to him, right? Well, here's this guy with I don't know. I don't know, 70 or 80 years of experience, right? Literally, right? And working in the basement uh, of his house in South San Francisco, right? And this is the guy that I mean, Robin's probably used one of these. Robin, did you ever use a three-dimensional Dactyl pantograph? Did you ever use one?
Only in the engraver version.
Engraver version?
Yeah,
Well,
not a machining version.
yeah. So this guy built one of these in his garage, right? He couldn't afford to buy one, so he built one. And this had these ball linear ways that he built, and the whole 9 yards. And he built his own cylindrical grinder, an optical comparator. I mean, this you'd go into his shop, and everywhere you looked, there was something that he made, right? And he he built his own decal in that well, almost. He couldn't afford to buy one, and a friend of his was traveling to Germany, and he brought back the I don't know what you call the module, but it's a thing that the collet mounts to, that little angle adjustment thing. But then he built the whole machine around it because that was all I could fit into his luggage and coming back from Germany. Right?
Well, that's because he didn't know Unix
anyway.
Carbide. Unix Carbide would have brought the whole machine in his luggage.
Yeah, exactly right. But here's so to Robin's point. Right now, there's people that are working away that don't have a computer, that aren't on social media, right? And they might be one town over from you, right? And working in obscurity, literally, right? So I think I'm certainly better off for kind of joining in on the social media thing and absorbing it, this great knowledge is just flying by, right? And these nuggets that people put up, that it's like, ooh, that's a good idea, right? And I mean, I've done it so many times, sitting looking at my phone. Ooh, that's a good idea. Save, right? And it's a great time to be alive.
How much has our clients, the people that pay us money for our work, how much has our clients benefited from the lubricant, which is social media, in our corner of the world, in machining and tool making and precision? I mean,
yeah, I don't know. The cross-pollination is staggering, right? And it's yeah, I don't know. Pretty cool.
Well, I think they should pay us more, is what I think they should do. Well, we had a couple of questions pop in here. Let's see. First of all, nothing but positive comments on this idea of going on to this white sheet of paper mission.
Hey, that's a good name for it. Clean sheet of paper.
Clean sheet. Well, we already call this Two Guys and a Pencil, so maybe that's the subtitle.
Okay, right,
is a clean sheet of paper. I like it. That's good. All right. Let's see. You guys don't. Ryan Carter says you guys don't do much for my eBay prices getting these tools, though. Well, yeah. I think there's a name for that. I think these guys are called enablers, is what it is. They cause you to start buying stuff. Let's see. Somebody had Ryan. Same Ryan. Ryan said, "Could we get a Robin meatloaf sometime?" So, Tom makes meatloaf. You might have to make, a bruschetta or something. I don't know, something else. But
Robin's very careful about collecting, though. He's much more he's space constrained. So he said it to me is, yeah, anything that comes into my shop has to earn its keep,
yeah,
right? And so
I don't know. I think
his
Go ahead.
his background there is 3/4 of his shop. Okay, so I've been in there.
Well, I think
Three people is a lot in his shop. Okay.
our discussions recently of cubic clutter credits, I think, may have been inspired by the lack of airspace in Robin's shop. Let's see who else had some questions here.
I remember trying to. Another guy and I visited Robin in his shop, and it was hard to find a spot to get a selfie that 3 people could be in.
Wow.
Oh wait, no, let's move over there. Oh wait, no, move over there.
That's pretty cool. Let's see. There was one other question here. I think we'll save that one. Evil's had a question about. Well, it's a good one. He says, I have a question about the center jigs. Are you allowing for easy initial precision setup and reconditioning in 50 to 100 years?
52. Well, not going to be my problem in 50 to 100 years. So it's, somebody's going to drag it out of an estate sale and go, what the hell is this thing? Right. And who knows, right? So.
I think the author Douglas Adams, he had the term for that. It's called an SEP, somebody else's problem.
Yeah.
Let's see.
The fact that we make them to begin with answers that question. We since we made the item, we instilled the initial precision. So doing it again is touching up for if something's worn is not an issue.
There you go.
Good answer.
AWD Junior Al says, great informative video, guys. Thanks for making the time and effort to post. I'm 68 and have over 50 years experience and still learning today. Al,
excellent.
You're awesome.
Good deal.
Let's see. Hassan says, as a replacement for grinding, would you ever consider lapping a hardened and ground bedways? As a replacement for grinding, would you ever consider lapping a hardened and ground bedways? On
Not
what?
Sure, I understand that question. Yeah.
Yeah, the bedways could be big, in which case I'm not sure it applies. Lapping is pretty local.
Well, it's a geometry improving process, right? But it's not really practical over gigantic areas, right? Or long lengths and things like that. So,
foundations of mechanical accuracy. The section in the cross slide of the Moore number 3 measuring machine. They show the act of scraping to have these nitroloy square sections inserted into the V ways there, and then the large outer ones. But then they show a large lap that they use to take the distortions caused by bolting and see them, and then also small hand laps for tweaking. But remember, this is tweaking very minute things, not going from as hardened surface. That would be totally impractical with lapping such a slow material removal process. But for fine tuning, the RAMs of coordinate measuring machines and all these things, they're all done to the best ability, but then there's people in there tweaking for that last little bit that are hand lapping sections, checking with an autocollimator, and seeing what's going on. And so that's tweaking with laps is good, tricky, but good. It's
they don't they're not moving a lot of material to begin with, so you better be only tweaking. At least with grinding, you can move some material. You're welcome, Hassan. Well, I think we did it, and this was just awesome. You guys are terrific. Thank you for sharing. I don't know what to say. Yeah, it's going to take me 2 weeks just to absorb. I have to watch the video again so that I can learn. I'm too busy. I'm too busy making sure we don't crash here. Yeah, Evil says, "Oh, come on, we're not even at 2 hours yet." Yeah, well, Evil's, we're gonna leave a little time between now and all agglomerating in the Discord server. So, any final closing remarks? I think we probably did it. Tom, you good?
Yeah, I'm good, and I'm ready for a bio break. So I'm probably going to bail here. Robin, good to see you, and thanks for participating.
Thank you.
And you've given me a couple more things to think about now, so that's great. So, well, no, it's things you didn't consider, and we both scrambled to push the designs along for this. So there was some motivation here too, right? To polish things up a little bit. So it helps us as well.
So I don't know when we'll pull off this next mission, the white piece of paper,
Sure.
but we'll talk, and everybody stay tuned, and we'll let everybody know. Robin, any closing shots?
No, it was fun, and glad to participate. Glad to for Tom and I to put our heads together, and it was fun as always.
Well, you are awesome. I thank you both. And this was Two Guys and a Pencil on PFG.Live. We'll be back next week on Sunday with some sort of excuse for talking about this stuff. And in the meantime, if you need something flat, head on over to PFGstones.com. Also, all the links to the YouTubes and the audio podcasts and everything has been agglomerated there, or you can go to pfg.gg and you'll find it there also. So thanks for being there, everybody. Get flat and stay flat, and we'll see you next Sunday. Take care.